So we have found the values of all the elements of this W matrix, and I can write them in this form now. We have zero values either, or then some terms are having V naught over 4. If I want to write this thing in terms of V naught over 4, this value, then I can write it as V naught over 4. So I will multiply it with 4 and divide by 4. So multiplication by 4 will make this one is 64. So I can write that 64 over 9 pi squared and V naught over 4. And this 64 over 9 pi I can write is this one V naught over 4, because I want to give the matrix a reasonable shape to be easy for the calculation. So this I can write is 8 over 3 pi whole squared and V naught over 4. And this 8 over 3 pi I suppose is kappa k or kappa, and this thing comes out to be equal to 0.7205. So it's just a value. I'm just representing it because I can't write this value again and again. So I will have to write the matrix now. The W matrix is equal to V naught over 4 taken is common, and then 1 0 0 here, 0 1 and kappa here, because I have WDC value, DC is equal to this, and then I can write 0 and WCB is again this kappa and 1 here, because WCC is V naught over 4. So all the diagonal elements, they are 1 1 1. These 4 elements AB, BA, AC, CA are 0 0 0 0 here, and the two values of BC and CB, BC and CB are equal to kappa, and kappa is equal to 0.7205 or this value, and then multiplied with this V naught over 4. So I have this matrix. Now this is equal, this I can write further that 4W over V naught is equal to this matrix, which is 1 0 0 and 0 1 kappa and 0 kappa and 1. And now I find the characteristic equation, the characteristic equation for 4W over V naught. So it will be just this determinant, and this determinant I will write is equal to, means in the form of determinant I can write, means which is the matrix W minus the lambda I, the equation which we use for a determinant, and then this I can write is, this will become a determinant, and then the terms will be the 1 minus W. So the identity matrix minus W, so 1 minus W here, and then 1 from all these subtract W, so 0 here, 0 here, and then 0 and 1 minus W here, and then kappa and 0 and kappa and 1 here. This is just the characteristic equation. The characteristic equation which usually we write is a determinant of this and lambda I minus this one. So it will be the identity matrix like 1 0 0 0 1 0 0 0 1, and we subtract it from here. I hope you know the characteristic equation. So this determinant, when I explain this one, then only one term survives here because this is 0, this is 0. So I have 1 minus w into the product of these. So I have 1 minus w, and then these two are being multiplied. So 1 minus w into 1 is 1 minus w, and then this is 1 minus w, and here, okay, here we are also having 1 minus w because 1 minus w, 1 minus w, 1 minus w. So it will be 1 minus w and 1 minus w, so it will become squared, and then minus kappa square, and this is equal to 0. So the limits, when this equation, I explained this one, it comes out to be, I can write this one in the form of a square minus b square. So it will be 1 minus w, and then this one I can write is, this is a square minus b square. So I can write this one is a plus b into a minus b. So it will be a plus b will be 1 minus w plus k, 1 minus w plus k are kappa, and 1 minus w minus kappa, and this is equal to 0. Now I have just factorized them, so it means that 1 minus w and 1 minus w plus kappa and 1 minus w minus kappa, they are equal to 0. So it means either this is 0 or this is 0. All cannot be 0. So we have now the roots of this equation is 1 minus w equal to 0 will imply that w equal 1, and this the w, so I will write this is w1 here, and then 1 minus w plus kappa, and this is equal to 0 implies that w2 is equal to, when w comes this way, it will come out 1 plus kappa, 1 plus kappa, and 1 minus w minus k equals 0 implies w3 equal 1 minus kappa. So we got these values. Now if I add the value of kappa with this one, then w1 is basically 1, w2 is 1.7205, and 1 minus kappa will be 1, this will be point, means it will be subtracted 1 minus 0.7, so we have 0.295. So this means that we have found the value of w1, w2 and w3. So here for w over v0 we have calculated, so it is 4w1, 4w2 over v0, 4w3 over v0. So we basically got that the initial energy which was E01, the initial energy, which was E10 or the first excited state energy. Now it has converted, or it has split it into three different energies, and that one is that this is the one energy here, the E1. Approximately this one shifts by how much? W1, when this is 1, so here is 1, so W1 equals 1, so we have V0 over 4, and this is the E10 plus V0 over 4, while the other energy, this E10, is modified, is approximately, okay, approximately this one E10 and plus 1 plus kappa and over V0 1 plus kappa over V0 by 4, because we have this 4 over V0, so W, it comes V0 over 4, and the other splitting is E10 plus 1 minus kappa and V0 over 4. This is like earlier we were having one excited state which was E10, the first excited state E10, and then that first excited state, due to the perturbation, it has now splitted and splitted like this, that the first energy, it is this one, and here this is 1 plus, this is E10 plus E10 plus V0 over 4, this one E10 plus 1 plus kappa V0 over 4, and this one E10 plus 1 minus kappa and V0 over 4. Or we can put the value of kappa and we can write then how much this has shifted, because 1 plus kappa means this energy has gone from the V0 over 4 this much up and this much down from this one. So the perturbation, this was E10, and we came to know that this is triply degenerate state, like the levels are 3 and the energy is the same. We applied Hamiltonian on this one, which was equal to V0, and that basically splitted the energy level for us into 3. So we have just saw with the help of that perturbation, and this was the degenerate perturbation theory that we applied, and we got the result like this. So with this we have like this was just earlier I gave you the example that here this thread, I know that it is made of 3 other threads, but they are just, you can say, interwoven, and I was unable to recognize this one thread is a 3 thread, and I apply a twist on this one, the perturbation on this one, and it splitted the 3 threads from each other, and this is the result of that perturbation. So the first excited state, we saw that it's triply degenerate, and we found those values as well. Similarly, uh, we can find the eigenvectors of this W, okay, and write the resulting states. So after this, let me do calculate this one as well.